This is Chaya Chandrakar from Sri Venkateswara College of Engineering. Today we're going to study about methods of temperature control and sound control in the buildings. So today we'll study about the challenges of modern world, goals of temperature control and sound control in buildings, and we'll know about temperature control in buildings and its necessities. In temperature control, we'll know about the passive temperature control and active temperature control, sound control in buildings and its necessities, and we'll know about the case study which will be about a residential apartment in Australia, and we'll have the summary of this video. The challenges of modern living: overheating, poor ventilation and excessive noise disrupt comfort. Buildings consume 40% of global energy, hence control is the key of sustainability. Goals of temperature control and sound control. So what do we aim for? Thermal comfort for all the seasons, peaceful and noise-free environment, energy efficiency and eco-friendliness. Temperature control in buildings and its necessities. In buildings, thermal control system contribute to occupant comfort by maintaining consistent temperatures and humidity levels. This is not only enhances comfort but also boosts productivity in work environments. The versatility of thermal control systems make them applicable across a wide range of industries. First, let's know what is passive control techniques. Passive thermal control in buildings is a design approach that uses natural climatic control to improve thermal comfort with low or no energy consumption. In this technique, it involves passive cooling, which is preventing heat from entering the building or removing heat from the building. Next will be passive solar heating. This uses a large glass area to let sunlight into the building. Natural ventilation and lighting. Using natural ventilation and lighting to improve thermal comfort. Indoor greenery. Indoor greenery is using plants inside the building to improve the thermal comfort. Reflecting pools. Using the reflecting pools to improve the thermal comfort of the building. So these are the examples of passive temperature control. First will be passive cooling, and this is passive solar heating. Next is natural ventilation and lighting, where there is a natural ventilation and lighting in the building. Indoor greenery, the plants are used in the building naturally, and the reflecting pools will be used around the building for the thermal comfort. Next, it is active temperature control techniques. What is active temperature control techniques? So active cooling requires the use of energy specifically dedicated to cooling the component. It requires the use of energy for cooling the component. And this process involves active thermal insulation, a system that connects the ground to a wall heat exchanger to reduce heat loss through the building's exterior walls. In one test, ATI reduced heat loss by an average of 63% compared to a standard insulation. Active thermal mass, a system that uses water or air to regulate the building's temperature. Water has a greater cooling potential than air, so it can be pumped through pipes embedded in the building's floor. Installing an HVAC system. So HVAC is heating, ventilation and air conditioning system. So this is one of the most effective ways to control temperature in many types of buildings. Use a smart thermostat. A smart thermostat can help you control the building temperature in specific rooms without affecting other areas of the building. Energy efficient system. Energy efficient heating and cooling systems can maintain a comfortable temperature throughout the year. Programmable thermostats and zoning systems can provide better control. These are the examples of active temperature control. First will be ATI, next is active thermal mass, an installation of HVAC system, usage of smart thermostat in the building, and energy efficient systems used in the buildings. Next, we'll study about sound control in buildings and its necessity. Sound control in commercial buildings refers to a process of reducing noise levels and improving room aesthetics. For optimal aesthetic comfort, it involves using materials, products, and noise reduction techniques to block out external noises, reduce unwanted noise transmission between rooms and floors. The technique here is usage of sound absorbing materials. The use of observator materials can be useful in controlling the sound by installing sound absorbing materials like fiberglass, rock wool, glass wool, cork, or foam panels in rooms that are potential sources of noise. Next is using aesthetic materials. Use aesthetic sealing around wall perimeters or add aesthetic materials like carpeting or heavy carpets in the building. Next, the technique of soundproofing can be used for the sound control. Soundproofing is the process of reducing transmission of sound waves from one space to another. Adding dense material to treatment helps stop sound waves from exiting a source wall, ceiling, or a floor. Materials include mass-loaded vinyl, soundproof sheetrock or drywall, plywood, fireboard, concrete, or rubber. Different widths and installation of studs in staggered manner. The use of sound absorbing blankets help to block the sound and acts as a very effective sound barrier. It will help to shield the home from external noise. The sound absorbing blankets enable the increase of sound attenuation. Usage of sound absorbing blankets. Studs are arranged in a staggered manner that helps to reduce the noise by absorbing it and reducing the intensity of the noise. The construction of staggered stud, you will get an extra hair cavity which helps in the slow movement of the hair that helps in the isolation of the sound in the buildings. Now let's see a case study where we'll know about a building in Australia where all the sound temperature control and sound control techniques are used in this particular buildings. Smart HVAC systems, automated heating, cooling and ventilation controlled by AI to reduce the energy use. Passive solar design, maximizing natural light and using thermal mass for temperature regulation. Insulation, high performance materials in walls and roofs to maximize heat transfer. Green roofs and passive vegetation that reduce the urban heat island effect and provides natural cooling. Sound control techniques. Aesthetic panels installed in common areas like conference rooms to absorb noise. Noise isolated partitions. Wall designed with soundproofing materials like loaded vinyl and resilient channels. Double-glassed windows provide both insulation and noise reduction from external urban sounds. Quiet ventilation system. Ductwork lined with sound-absorbing material to minimize sound from airflow. The outcomes of this project are energy savings, 30 to 40% reduction in energy costs due to integrated system. Sustainability, reduced carbon footprint and long-term operational savings. So this building is One Central Park, which is in Sydney, Australia. The conclusion of this slide is building for a better tomorrow, which will be useful and which will be efficient for our daily lives. Prioritizing sustainable and innovative designs, which will be for our welfare. So the best buildings are silent and comfortable guardians of our lives. Thank you for watching the video.